Hi. So in this section, let me tell you what I am going to explain. So I am going to explain about following agenda. We are going to explain about package creation, import, Java imports, encapsulation and scope of the variables. Then we will talk about object creation. Then we will talk about methods, a lot of things on the methods. Then we will take static and non-static variables. Then we will take about final variables and methods. And then we will talk about inner classes. Then we will talk about memory and garbage collection. Okay, so let's talk about package import and encapsulation. So what is package here? Package, in last videos, as I said, package is a logical grouping of your Java classes. So based on the modules, you can club those classes into a package and use that. So of course, if you are doing multiple package, so they have to invoke the classes of one package to another package. So let's try to create a package. Let's go to our Eclipse. So in Eclipse, as I already have created, so it is pretty easy for you to understand. So say we have created one package called com.training.java.basics. So here I have included all the basics classes related to basics. Then I have created one another package, that is com.training.java.basics.examples, where I have included most of the examples in this package. So how do you so this is way you can create the package. So suppose you are creating a class, for example in this SRC, I go and create one new class. So while creating the class, it asks for package. So if you see, it asks for package. Right now, if I don't give any package, it is fine. I don't need to provide any package. So it will create into a default package. So how to create the package here? I have to say package. Then if I keep com, my com is package. So right now what will happen, if you see here, it will give a compilation problem because I have to create a package first. Then I can say that this class is part of this package. This class test package is part of com package. So what I need to do, I need to either move this class to Java class to test package package.java class to package com. So if I do that, it automatically creates one package and move this Java file inside this com package. So let's try to do manual. Let's move this class again to default and remove this com. I'm going to that package. So if I say package com, so what I need to do, I will create one new package over here. Package is nothing but just a folders you are giving. So I would say src com. So it says that com is already there. How? I am not seeing any com package. Oh, com is already there, right? So if you see here, this is again a package. So let's go to the folder structure of that package. This is available here. I'm going there and opening into folder structure. So if you see here src, we have com. So every folder is kind of package. So com is already there. So what I need to do, I have to move that Java file to into the com. So right now this package is here. I can do here, copy it and paste into com. So once I refresh it, it should be available here. Because I have just copied, I have to do, I can remove from here, or you can do removal from anywhere, it doesn't matter. Sorry, I have removed from com package. Let's undo it and remove from default. Default is nothing but from where your SRC starts. So now we are done. So one class will be inside this com package. So this is how you will create the packages. Now let's talk about another section, which is about import. So when you create the package, so when you are trying to do cross package coding, so suppose you are in package com, you want to access something from com.training.java.basics or com.training.java.basics.examples. So that is the place where you need to use the import. Import is required when you are trying to access some class, when you are trying to use some class which is not available in your current package. What does it mean? If you need to use any class which is available in your current package, then importing of that class is not required. It means that suppose I create another class here, say test import. So in test import and test package, both are in the com package. Suppose in this I write one main method in test import, and I want to use, say, test package. Let's create one static method. The static method name is method, and return type is void. Just a method I have created. I want to use that inside test import. So I have to use test package dot method. So if you see here, to use this one, I don't need to have any import here. There is no import statement. It means that if you are trying to use a class, anything which is available in this com package, you don't need to import. Same time, if you want to use factorial, so factorial I want to use in this method, say factorial fact. Here, because this factorial is from other package, you need to write one import for this. So this is how you need to do. When you are importing something, when you are importing some class, it should be available outside of your package. Inside the package, it is not required. If you write one import for your test package, so you can write it com.test package. You can write it, but it is not needed. So when you say organize the import, then it will remove it automatically. So organizing import is something like you can do using source. Somewhere there is organize import, Control Shift O. So if you press Control Shift O, what it will do, it will organize your import. So it automatically understands that which import you need or which import you don't need. Suppose you have created import here com.test package because you are using test package, and but you know that it is not required because you don't need to import the class in the same package. So when you do organize import, it should remove the test package import. So similarly, as I said in the beginning, java.lang. anything, lang.start means any class inside this package. So java.lang package, you can say that package is already imported in every class file. So whenever it is not required to import it. So if you see here, it is coming with yellow color. So it says that import.java.lang is never used. So you have to, it is giving suggestion that do the organize import and remove unused imports. So I will do organize import. So it will remove all the unnecessary imports. So imports, you understood that import is required when you are trying to use any class which is not available in your current package. Then it is import is required. So right. So let's move to the next line. So we got how to create. Can we create an existing package? What does it mean? You know that in Java, a lot of in Java, what happens in lang.string, right? Suppose you are using java.lang package and you want to use lang.string as an object. Suppose you want to use string. So you know that in this example, if I use string s, I just declare string s. So string is available in java.lang.string. So what happens if I create same thing? I create one class, new class in the same package, say string, and package name I am creating as java.lang. So what happens here? If you see, there are existing classes where I have used string, say happylearning.java. It says that this constructor is not available. Means that it is trying to access the string class which you have created, not the one which is available in java.lang package provided by sunjava. So this is also advised that don't create a similar class, same class in the same package that provided by Java. It will create a lot of conflict and your JVM will be completely confused. So it can cause compilation problem as well as your runtime problem. Suppose what happens, suppose I have removed this class, remove this line just to ensure that you don't have any problem with here. Also there are a few things I have cleared, so it's okay. So coming back to the test import where I am running this test program, there is some error with the project. So before proceeding, you can fix those compilation problem, or because you are only running test import which doesn't have compilation problem, you can proceed with running. So what happens? Because you are not doing anything, it will not have, you are not accessing anything here. So let's try to do something new, string. Done it. So basically in this class, in this test program, you are not trying to do anything, so it will not happen. So I advise you not to create anything which is having the same class in your sunjava. That is not needed. And if you do that, it will override the sunjava class with your new class, and which doesn't have all the capability of the class which sunjava provides. If you can write that kind of class, it's up to you, you can use it. But that could be the waste of time. Okay, so I will remove this string class so that everything will be fine. So here also Okay, so we have understood how to create the package, what is the purpose of imports, and why we should not write the same class with the same package as Java provide itself. Let's move to the next. So we have said, do we need to import other classes present in the same class? So we tried importing the other classes present in the same class, so it is not needed at all, right? Let's talk about what class contains. A few videos back I have explained about what class contains, so let's do little bit more about that. So let's talk about, say, com dot, let's go here, let's create one class called test. So no class beta, simple. So in this class, what is happening, I'm going to explain what it contains. So this class should have the name as your Java file, and it should be a public class. So inside this class, what we can have variables. So let's give some better name. Let's create a employee class instead of this. Okay, so if I have changed the class name, I have to change the Java file name as well. Okay, so let's use the employee class. So first thing what it can have, that is variables. So if I say employee class has int ID, identifier, and it has some name, okay, and it has some methods. So methods, I will say set ID, where I'm setting ID int it will be wired, okay, and similarly I may have get ID. Okay, get ID will not take any parameter, it will return one int, and it will return ID itself. Okay, let's have two methods. So it has variable, it has methods. Okay, then it may have some static block also. So static blocks are those blocks when your class will be loaded into the JVM, that static block will be executed first. Okay, so I will use one static, and I say in static block. Fine. Okay, now apart from that, it can have some classes which are known as inner classes. So inner classes are classes which are required, which are useful for this parent class, say employee. So I will say class employee address. So this employee address can have address and few methods also. Let's put while set address. I am passing address as variable, and setting this parameter to address to this address variable. Okay, so I have inner class also. Apart from your inner class, there could be constructor. So constructor generally we write on top. So constructor is constructor. So constructor is nothing but a method or method which have same name as class name. This is the contract of the constructor. It should be with the same name, right? So I have created one method which is public and name is employee, and the contract of this one is you cannot have any return type of your constructor. It should be always by default void. If you provide also, it is fine. If you don't provide, that is also fine. So it should have return type as a void or no return type, or you can say that and you can say that it should have the name of the method should be as same as employee name, employee class name. Okay, so these are the things which you can write into a class. So you can write private, you can write variables, you can write methods, you can write static block, or you can write constructors as well. Let's move to the next one. So it has method, it has methods, variable, static block, inner class, and constructors. So let's talk more about constructors. Let's go a little bit deep about constructors. So okay, so there is constructor is like this. This is called default constructor. In this default constructor, if you don't write also, there is default constructor. Why we need to write a default constructor like this? If you want to define something, if you want to initialize something, or you want to do something which you want in your default constructor, then you can do it. I am just saying that in default constructor, right? So the other flavor of constructor, because this is a method, you can parameterize it. Means you have to give a parameter. So I am giving name, string name. So once I create the constructor, I can use this name to do any activity. So what I will say, whenever I will call employee constructor, I will pass the name, and that will fit into the name available into this class. Okay, so here this is the name. So because let's give another one, provided name. So I will say provided name. So this name is equal to the name, which is the variable of the, which is a property of that class, that will be populated with the value of this parameter when I use a constructor like this. Other form of constructor, so one is default, one is, this is default, let's say this is default, this is parameterized, and third one is private. private constructor. So private constructor, I will tell you what is the purpose of private constructor. So private constructor is nothing but, this is a similar thing. You can say that, remove it and say private constructor, because you cannot have public constructor and private constructor as a default constructor, because this is the two methods with the same name. So one have to remove, right? So I will say in default private constructor. So when I will tell you the scope of any variable in the class, I will let you know in the detail about private constructor as well. So for as of now, you can understand that there could be default constructor and parameterized constructor, and any constructor you can mark as a private. Okay, so let's move to the next one. Let's try to understand method, variable, access, modifier, declaration, private, protected, public. So that's basically encapsulation and scope of the declaration. Let's talk about all those things here. So let's create one test class. Okay, let's leave that. Let's understand here. So let me go back to the topic again. So we are going to talk about access modifier declaration, that is private, public, protected, and basically in terms of that how we do the encapsulation and scope of declaration. Fine. So let's first talk about encapsulation. Okay, let's first talk about encapsulation. So encapsulation is basically binding your variables with methods. So in this example, in this class, I have variable as ID, employee ID and employee name, their ID and their name, and I have said that, and those things I am marking as a private, and I have set methods and get methods which are using this ID, right? In the set method I will say you can say given ID. So I will say ID is equal to given ID. So here what is happening, if you see what is happening here, I have ID as a private. Private means, okay, let's do one thing. Before understanding this encapsulation, let's try to understand the concept of private, public and protected. Let's understand and use it first. Okay, so private means it could be private variables, and it could be private method, and it could be private class. So private class, if I say private, let's take the same thing. I said variables. Let me put this one on top so that it will be more visible. So if I say private, I can access this ID within this class. So the scope of this ID is within this class. I cannot access this ID outside of the class. So that's the reason I have put private int ID, private string name about employee. So these two variables can be accessed inside this class. It cannot be accessed outside. That's the reason it is private. When you talk about private method, same thing. These methods can be called inside this class. And when I say class, this could be a inner private class which can be used inside this employee class. So this is how private is there. So when we talk about public here, public variables. So public variables, if I put here any, say, public string address, so if I say public string address, I can use this variable outside of this class. Anything public inside this employee can be used outside. It can be used inside also, but it can also be used outside. When I say outside, outside means anywhere, across package. Okay, and when I say methods, I can write public methods, say public void set address, string address. Okay, I'm setting address equal to, don't go about variable names right now. Here I'm using address, here I'm using add. I will tell you one concept called this later, where I will tell you later about this. Okay, so for now you can say that whatever variables you are giving, give a name and use it. So this is how I will give the public method. So public method can be accessed from outside. Let's talk about protected as well. So we have covered method, class. So any class you can write inside this class, that will be inner class. So if that class marked as a public, that class can be used or accessed outside of this employee class. So that's how your public class comes into picture. So let's talk about we have discussed public variable, methods and class. Let's discuss about protected. So protected methods and variables and class. So they can be accessed inside same package, right? If employee is here, it can be accessed all the classes inside this package java com.training.java.basics. So any class inside this package can access the protected variables and methods as well as class. Okay, so inside same package, same time in inheritance, it can be used. So inheritance I will take later. So what does this mean? If a class, if class A extends class B, okay, and class B has some variables as protected or method also. So what will happen? Those can be accessed in class A. So I will tell you in detail when I will go to inheritance. So for now you understand that protected can be accessed, protected variable, method and class can be accessed inside the same package, or when that class will be extended by, when that class say B will be extended by class A. So in that case class A can access all the protected variable and methods from class B. Okay, let's try to see this example. So let's create one class called, let's create in class example called test employee. Let's create one main method. So let's play with your access modifiers there. Let's create one example, employee class. So I'm creating one employee object. So okay, so I will tell you little bit later how to create the objects. So this is just to understand that this is the way we can create the objects. I will take you later. So here we want to see the accessibility of the classes, class variables. So let's put the context there only. So if I create an object, let's see what we can access. EMP. If you see here, suppose in the employee class, let's close other things. So in employee class I have said private int, can be accessed private int here, sorry, private that is ID. I cannot access because it says that it is not visible. So suppose you try to create any method on, if you have any method. No, you don't have any method. So let's create a method, private method. So if I create a private method called my private method and say while, so this is also not available here. So it means that private cannot be accessed outside. Let's try to access the protected. So have we declared anything protected? No. Sorry, before that let's try to access public. So public, let me check what we have public here. So public, we have few things. We have public address and we have public method as well. So emp dot address, I can change, I can provide the value of address, and I can say set address also. So I can access the private variables and private methods. Let's try to give a protected things. Let's protected, say protected variable. The type is say int. Okay, and let's create protected method. Provide my protected method. Okay, let's try to see if we can access. I cannot access anything protected method also. So let's do one thing. So we have seen that we can access private, we cannot access private, but we can access public. So let's try to see how we can access protected. As I said, either way we can do. So let's put this test employee class into Java Basics. Okay. Here, right now it is in Java Basics, where we have so if you see that this employee class was imported here, which is not required, I can remove it. Now I can say emp protected variable I can access. Okay, and I can access protected, my protected method also, right? So to access protected things, I have to be in the same package where employee was there. So let's remove this employee class from basics where employee was present. So we have another test employee which is available in the other package. So the other way of accessing the protected was extends employee. Don't worry about too much about here. So I will tell you inheritance later. Why you are not able to access, I will do little bit adjustment, so you don't need to do that one. Okay, so let's not worry about extending. I will tell you inheritance later. So the focus here is how to access the protected. So because I have test employee extends that employee, so it can access, this class can access the protected member of the employee. So something is wrong. So when I say instance, it means that you can use access the my protected method, means you can here override. So let's not worry about using the protected method in the extended in the inheritance way, because this way it will confuse you. I will tell you how to access the protected method when I will explain about inheritance. So for now you can ignore this particular concept. So we have what we have discussed so far, how we can access the private, protected and public methods of a class. Including the variables as well. So let's move ahead. So we have talked about encapsulation, where you are binding your private variables and public methods. Why do we do that? Let's go to employee, and as I said, I have private integer ID, employee ID, and private employee name. Okay, and we have corresponding method, and these methods I will make public. The purpose of doing this is encapsulation. The purpose of doing this is encapsulation. So when I try to access employee, I have not to worry about what is inside variables. So those variables ID and name, those are exposed outside as methods, in terms of methods, in the form of methods. Suppose you want to change the value of ID, you have to use set ID outside of your class. So if I say here emp.id, ID is not available directly, right? ID is not available. So what I will do, I will say set ID 12. So doing this way, I have set the ID parameter to 12. Now I can get it. What I need to say, emp.get ID. So if I do that and run this class, so I can say that I have value 12. Okay, I have value as 12. So here encapsulation, what plays role here, you are setting the attributes of a class, not using directly those attributes. You are setting those values of those attributes by using setters. So by using set methods, and you are trying to access those values, you are using get method. So encapsulation is binding your variables, binding your private variables like this, binding your private variables with your public methods. Okay, this is about how you are doing the encapsulation. So scope of declaration here is whatever, suppose you have private and public. So private will be available inside these methods, private can be accessed inside these methods, and public can be accessed outside of this class. So anything what you mark as a private, your variable or your method, those things can be accessed inside this class. If it is public, it will be accessed outside of the class as well as inside the class. Okay, so we are done with this slide. We will move to next in the next video. Okay, so let's talk about creation of object. So we have so far we understood how to create the class, how to create the package, what is the access modifier, what is public, constructor, everything we understood so far. So we understood how to create the methods, what is the accessibility of methods, what is encapsulation, how to do the binding of your private data type with your public methods, so to maintain the encapsulation, and few concepts we understood about accessing protected method, accessing public method, accessing private methods or variables. We have talked about little bit what things we can contain into the class. So in this slide we are going to explain about how to create the object. So creation of object is very much required. Why we do that? Without creating the object you cannot access the elements of your class. There is exceptional case if your class has some variables or methods which are marked as a static. Those things you can access, otherwise you cannot access anything inside of your class, any element of your class. It could be variable, it could be method, unless you create the object of that. So let's create the object of that. So when we create the object of that, what we need to look into that, what is declaration of object? What happens when you declare the object? What happens when you create the instance of the class, that is object? So there is a little bit difference. I will talk about that. So declaration of object is just a reference or a memory address to the object pointing to the actual object. So in Java, when you create an object, it will basically you are creating a reference or memory address of the object, and it will be pointing to the location where your actual object is stored into the heap memory of Java virtual machine. So in your Java memory, when you create an object, it will go into a heap. Same time when you declare a primitive type, when you declare a primitive, it is basically you are having some values of those primitive data type, and which will be available in your stack memory. So object will go into heap memory and variable will go into stack memory. So variable of a class type, it stores an address of the object and not the object value themselves, which are stored that address in the memory. Declaring primitive type, it stores the value in the memory, that is stack. So how do we create the object? We will create the object by using new operator, new, new operator. New is the keyword, so it is a Java keyword. So using new you can create the object. So what happens when you create the object? When you create the object, as I said, it will create a memory into a heap, which is what memory that much required for that object. When you create a object, it calls the constructor. It can be default constructor, it can be parameterized constructor. When you have constructor, default constructor as well as parameterized constructor, you have to be specific what type of constructor you are calling. You are calling the default constructor or you are calling the parameterized constructor. If there is no parameterized constructor, then you are calling the default constructor. Okay? Then we will talk about this. This is basically this basically denotes the current object. If I say this, it means that the current instance of the object is called this. Then we talk about null object. So null object is nothing but a object reference, or you can say object, a variable of some object which doesn't have any reference, which doesn't have any memory address to any location where object is being referenced, used, stored. So there is no memory reference, a memory address, or you can say there is no reference. So that way we will say that null reference. It is a null reference. So let's get into the working. So let's close this one. Okay. Let's go to the test employee class again. Here, how we have created the object here, we have created the object using new operator. So when I say new operator, this is the way you can create the object. So if I say, what is in this line, let's understand this line better. So this line, employee is type of object. Employee is type of object, and emp is name of variable of type employee, or you can say object name, and it is a reference to one object of type employee, and emp is denotes memory address of the location in heap memory of Java memory. We will talk about Java memory and how it does the allocation and deallocation in detail. So it denotes memory address to the location in the heap memory of Java memory. Okay, so and new is a keyword. That keyword is used to when you create the object, and using constructor you will create the object. Is the constructor. Okay, so right now if I go to employee class, I have one default constructor. Let's rewrite this one in new class. Basically I will rename this one to word, and I will create a new class. I will use a new class. So new class, let's put into the same package. Create a new class. Employee. Okay, why I am creating new one? Because I want to explain few things from fresh. Okay, and let's do one thing. Let's remove everything else as of now. So that you can understand this one program better. Okay, because it is in same I'm using the employee class from a different package, I have to give a different, I have to import it. So once you do the organize import, it will remove the unnecessary imports. So now we are trying to test employee. I have created one object. So right now employee has nothing. So when you have a class, will always have default constructor. So this class will always have default constructor. So I can create the object using default constructor. So let's move this one here. So let's try to EMP. If I run this program, it basically give you a address of your employee in the memory. So you can say that this is the class including package and its address. So when you create the object, it will create the address. It will print the address of this class. Suppose you just declare it. So there is difference between about any variable declaration and there is another thing called definition. When we say declaration about variable and declaration about method and definition about similar way, definition about method and definition about variables. Let's understand this point very carefully, because you will be hearing declaration and definition many times in your Java programming coding. Okay, so declaration of variable is nothing but just giving not initializers. So in the case of primitive, if I say int x, it is I'm declaring int x. Okay, in the method, if I say method, that's all. So it is a declaration of method. No definition. So when I say definition, in case of primitive, it is with having some value. In case of method, it will have method name as well as its body. Correct? In case of objects, so variable can be type of primitive as well as object. So if I say employee EMP, it is a declaration. When I say employee EMP is equal to new employee, it is a definite. I have defined one object. So it means that I have created the object. If I say, if I don't do like this and try to print the value, right now it says that I have to initialize. So by default initialization is always null. So it is a null reference. Once you run it, it will print you null. Okay. So when you create the object, and Eclipse has like something, when you declare an object or when you declare a primitive type, you have to give an initial value. So by default initial value of any object is null. So it means that it has null reference. It doesn't have any memory address to the location where any object can be stored. So as long as you are giving null, it means that you have not yet created the object. You have just declared the object and which is currently null. Okay, so let's go back and say new employee. So employee class doesn't have anything.
So we have just created the object which doesn't have any parameter or any attribute or any methods right now. So this is right now of no use. This class is of no use. Unless, let's make the purpose of this use. So when you say constructor, I am creating employee constructor. So constructor is nothing but the name of the method which has same name as constructor is nothing but a method which has name as same as class name. So if you see here what happens, if you have created a employee which doesn't have any accessibility. So if it is accessibility is not there, then it is a default accessibility. Default accessibility is always package. So because it is not in the same package, it doesn't have any accessibility, so I have to give public. So it is a public constructor, so you are able to create the object successfully. So by default it will have a public default constructor, any class. If you are providing, you have to do like this. There is other constructor called parameterized constructor. So if I give, say I am giving ID here. Okay. So if I give like this, I have to create the object using a specific constructor. So if I am using constructor, this constructor is also there. So if I remove this constructor, you cannot create the object because using the default constructor. So you have to pass the value of into that constructor. So what it says? It says that if you have any parameterized constructor, you cannot construct the object using default constructor unless you have default constructor. If you have default constructor, then you can use it. So you can create one employee like this, another employee like this. You can do that. But if you don't have parameterized, if you have parameterized constructor only, so it will not give you default constructor. Okay, so that way you cannot create like this. Fine. So let's do one thing. Let's use this class as a private. If you use private constructor, you cannot create the object outside of the class using the default constructor. Okay, because that is not accessible here. The purpose of writing the default constructor is to not to create the object from outside of the class. Okay, so we will use the public constructor. Fine. So next is, let's make this class little bit meaningful. So I have, let's put ID and let's use encapsulation. I will put private ID and I will put private string name. Let's use 2. Eclipse has one facility to create the getters and setters, so it understands the importance of encapsulation. So whatever variables you have created, it will create the public set value and get value. So like you can say setter or getter. So I will use this term in my course many times, setter and getters. So this is how you can create the setters and getters. So here if you said parameter name is id and say this dot id equal to id. So if you remember in the last example I was giving a different name of the parameter which is different than this one. Then I was saying that suppose I was giving id1, then I was saying that id is equal to id1 because I wanted to explain about this later, so that's the reason I did. So the purpose of doing this one, so you can give the name same, and to denote the current object's attribute you have to use this. So this is used, this particular keyword is used to denote the current object. So I have created the employee ID. If in this constructor I am using this dot id equal to id. What does it mean? When I create the object with this constructor, let's remove this constructor for now. So let's create the parameter. Let's use the parameter 1. Okay. So far if you print it will print the same thing. If you remember, right now the address is coming this one. Address is coming 7272. If you run it again, it gets changed. So when you are running the program, it's not necessary that it is going to use the same address in the memory, so it can use the other address. So that's again, whenever you will create an object, you can get a different location. So right now I am creating the employee object and I am setting that value. Now I want to get the value. So you cannot access any private variables, so you have to access using their getters. So if I say get id, because when I created that I have set this dot id into, I have set this id into current object id. So if I am creating the current object here, so right now I have set it into that object, so I can get it. So I should get the value as 12. Fine. So understand it again. If I am creating the object, so in this constructor I am setting the value of id current object to the current object's id by using this parameter id. Okay, so let's do one thing. Let's give another parameter shift. So because I don't have any such constructor, so I can adjust the constructor by modifying it. Say name. So I would say this dot name equal to name. Okay, so here I have set those properties by using constructor. Okay, now you can get the name as well. If you run it, you will get the name as well. So another way of doing it, if you suppose you don't want to, you want to create the default, you don't have default, so let's create the default constructor, and it has to be public. Remember that should not have any return type. you can have void, which is kind of no return type. So here I want to set the values using set id 15, say 23, and emp dot set name, say Sam. So when I have set the value to that object, and I can get it. Right? I am printing the ID and name of that. So this is how you are calling your constructor and using your methods. Okay. So here we have covered almost everything. So we have declared the object, we have using the new operator, we have talked about how it is going to allocate the memory, we have seen that what is the memory address it prints, we saw that default and parameterized constructor, how it will be used, what is this operator, and we talk about null object. Let's talk more about static versus non-static. So static is basically when you load a class, it will create all the static member of the class will be loaded at the time of class loading. That you can use it. So as I said, it will be available at the time of loading. So no need of instantiating the class, no need of creating the object to use those variables or methods. So let's try to go through about static methods, variables, and class. So static class I will take it later when I will explain about inner classes. Let's talk about static methods and variables. Okay, so let's go to the Eclipse. So let's close everything and let's create one class called static class. So in a static class I am giving say public static counter, and the variable of type is int. Okay, so this value is available, this variable is available while loading the class itself. So I can create one method say initialize counter. This method I will create as static void, and so what it will do, it will just do the counter, it will just do the increment of the counter. Remember that if I create one int x, I cannot call this x inside this static method. So the concept is static method can't call access use non-static variables methods class. The static method cannot call, access, use non-static variable method class. So inside this method I cannot call any, say I have some, right, I have some method, say method. So if I want to call this method, I cannot. Okay, how can I call? I can call by making object of the class. I can not call directly like this. Okay, so this is how I wanted to talk about that. So inside static method can't call access non-static method variable directly, right? It can call by using it can use by instantiating the class. So that is a thing which you need to remember. So I have created one static class where I have put one counter. So I am using one static. So let's create one static class test. So say test static class. So here I want to use static class dot let's put public so that I can access it. Okay, so let's write one main method. So in the main method I will use static class dot initialize. So it will initialize, and let's see the value. What after initialization, what is the value? Counter. If I print this one, this one. See here, I have not created the object because those things are can be accessed statically because that is available while loading the class. I could do that if I say static class. I could do the same thing. Static class 1 is equal to new static class, and then I say class dot initialize, and then I say class dot counter. This way also I can get the same result, but the purpose of doing static is no need to create the object. It is optional. So what happens if let's try to increment this one, public static void increase. You can say that whenever I create the object, let's increase this counter. So here it will be as much time you will access, it will become, it is it is the 1, the output will be 1 because we are just doing the initialization. So let's try to create the object. I am creating the object, not my purpose of creating this object is not to initialize something else. So I will say class is equal to new test class. Okay, then this class should be it should be static class. Okay, of course it has to be public. So in this class I have initialized, first thing I have initialized. Then I am creating the objects. So after initialization, let me print the value of counter. And after initialization, let me print the value of counter. So before initialization, it is 1. Once I created the object, it incremented the value, and then it will give the current value of the counter. So if I do this one again and again, I cannot have duplicate variables. That is very much basic. So if I do that, I will see values are increasing. As many times I am creating the objects, values are increasing. What if I don't give a static here? Okay, so because I cannot use, so let's static class dot counter plus plus. Okay, so it means that whenever I will create the object of this class, this value will be default. This is not a static actually. So what you have to say, you have to say every time you have to initialize the object, static class, then say counter. Same way you have to use the object to access the counter value. So let's see the output. So it is always 1 because whenever you are creating the object, it is initializing the value to 1. So because here you have already initialized, okay, so it is setting the value as 1. Next time you are creating the object, so let's take one example. In the case of initializing, I am giving the value counter plus plus. Okay, then I again say counter I want to initialize, let's give the value of 2. So first time so once I run it, so it will become, so when I do the initialization, it will become 3. So next time the value is already incremented to 3. So once I create the object, it will become So once you create the object, here it is happening counter plus plus. So it will increase the value of to 3. So let's do one more thing. Let's do the counter plus plus twice so that we can see the difference. Okay, now initialization of the counter is making it 3. Okay, but the object creation is making it 4. So once you run it, you will see 4 4 4. So while initialization, why it is happening, in initialization also you are making it, you are doing the counter of 4, correct? So after doing this, 2 is incremented to 4, but counter plus plus is happening after that, correct? So that's the reason it is always printing 4 4 4 4 4. So this is the way you can, how you saw the difference, how you are calling in a static way, how you are calling in non-static way. Let's convert back everything into static. Okay, so let's do it here as well. So we are back to the original result where it is going to increment the value. So a static is used when you are initializing one variable from in the class, and on the operation of the execution of any operation or method, you are trying to change the value of that one, and that value will be refreshed and it will be available for the next call of the class. So this is how you can see the difference of static and non-static methods. Okay, so let's talk about final variables. Let's create one class called final variable. So final variable means that is in terms of variable. There could be final in terms of class, in terms of methods as well. So here I will be explaining about only variable. So let's not discuss about class and methods. I will tell you when we talk about inheritance concept. So final variable, it could be primitive, it could be non-primitive. So primitive or non-primitive, suppose you have, let's write one main program. Suppose you have final int x. So when you say final, it has to be initialized. So I have to give a value of that. So final variable means the value of that variable cannot be changed. When I talk about primitive, the value of x cannot be changed here. So if I say in the sysout, in the main program, if I say s is equal to change, if I want to change, it is not permitted at all. So if I print x, Okay, so it should be static, because I cannot, as I explained, I cannot call non-static into static, because main is a static method. So I have to mark whatever I am calling, I have to mark as static. So if I call, I will get the value of 10. So in terms of final primitive, the value cannot be changed. In terms of, say, non-primitive, say let's, non-primitive means any object. So let's create one object of employee, new employee. Okay, I am employee, I am setting what happened. So I am creating this employee object, and there is one method, say change employee detail. This method I am creating inside this class. So of course it should be static. I want to use in main method, and it's wired. So here in the employee, I am setting the ID as 12 and name as Shiv. Okay, then if I want to use employee dot get, okay, let's create this object inside this method. So I will say get name, okay, and I will print name dot get name. Okay, so if I run this one, I can get the value like this. Let's make it final. So far I will get this one, same thing. Let's change it. Change, I will pass this employee. Okay, so I have not written anything in the change employee. So again, if I, because this value has not been changed, I should get the same value, right? So in the change, I will set ID 15, 14, and I will say emp dot set name Sam. So after doing that, what we can see, the value has been changed. So what is final here? You might be wondering, if it is final, why I can change the value. Okay, so in terms of primitive, what we understood is the value of the variable is final. Okay, in case of object or non-primitive, the reference of the object will be final. It means that you cannot create another reference, but you can change the detail of the same reference. So here I have created one reference of employee. Okay, then I am passing the same reference, and the same reference I am changing the detail of that reference. So this is not the actual final case of employee. So here, in the case of any non-primitive value object, so in that case final means final reference. So you can change the detail of that reference, but you cannot create a new reference. So if I do something here, emp is equal to new employee, and then pass id as 14 comma value as Sam. So here what I can do here, if values are not at change, because here this reference is completely different from the reference what I passed. Okay, so okay, so what happens, how we can prevent here the final? We can prevent here if I use emp see, final is not permitted here because the value cannot be changed, a new reference cannot be created because emp is final here. So this will give you compile time problem. So once you create a reference of employee, you cannot create the another reference, another object with the same reference. So that's final means in case of non-primitive. Okay, but you can easily change the value of the same reference. That is not the case of final. So in case of, to summarize it, in case of final of the primitive, the value of the primitive data type is final. It cannot be changed. Okay, in case of non-primitive, the reference of the object will be final. So detail of the same reference can be modified, but reference cannot be changed. So with the same reference, another object cannot be created. Okay, so let's talk other things in the coming videos.